Good evening. In today's session, we are going to see about the LED bulbs, that is the light emitting diode. Introduction. As an introduction, the light emitting diodes are the most widely used semiconductor diodes amongst the all different type of semiconductor diodes available today. The LEDs emits either a visible light or invisible infrared lights when it is in forward bias. The LED which emit invisible infrared lights which are used for remote control. LED, that light emitting diode, is an optical semiconductor device that emits light when the voltage is applied. In other words, the LED is an optimal semiconductor device that convert the electrical energy into light energy. When the LED is a forward biased, the free electron in the conductor conduction band recombines with the holes in the valency band and releases energy in the form of light. Regarding the construction of LED, the construction is similar to that of normal PN junction diode, except by using the materials such as gallium and phosphorus and arsenic materials are used for the construction instead of silicon or germanium material. The LEDs consist of three layers, that is a P-type, N-type and depletions layer. The LED constructions, in LED constructions, see the diagram nearby. The junction region of the diode is enclosed or covered by an epoxy resin of transparent plastic material, which is covered. The LED is covered by. The shape of this shield is hemispherical. The light emitted by the germs is not that much visible radiations, hence the hemispherical shield is used to have sufficient reflections from its surface towards the top of the device, that is the P region. This is the region how the brightest light at the top of the surface of the LED. Regarding working, the LEDs works only in the forward bias conditions. In forward bias condition, free electrons from the N side and the holes from the P sides are pushed towards the junction, that is the center part depletion layer. The free electrons reaches the junctions or depletion regions. Some of the free electrons recombines with the holes in the positive ions. The free electron combines with the holes in the depletion region. In similar way, the holes from the P side recombines with the electrons in the depletion region. The free electron in the conduction band releases energy in the form of light before they recombines with the holes in the valency bands. This is the diagram. Here the free electrons, that is the N type, and the P type. In P type the holes moves, holes. In P type the holes. Center part is the depletion region. Similarly, the materials such as silicon and germanium diodes, so the most of the energy is released in the form of, if we use these materials in the diodes, the energy is released in the form of heat and emitted light is too very small. So however, the material is calcium arsenide and calcium phosphate, the emitted photons have sufficient energy to produce the visible light. So for LED, we use the materials gallium arsenide and gallium phosphate. The application of the LEDs are as follows. Alarms, calculators, picture phones, traffic signals, digital computers, multimeters, microprocessors, then digital watches, then automatic heat lamps, then camera flashes, then aviation lightings, and so many applications nowadays we use the LED. This is the construction of the LED bulbs. Has 6 important components. That is the base. First one is the circuit. The next one is the base, and third one is the driver, which convert the AC power supply by the fixture into 12 volt DC to run the LED. Then next fourth part is the heat sink, which dissipate the heat generation by the driver, and fifth one is the LED module, that is a circuit based area, which array of LEDs are present there, which produces the lights in that LED modules. Then last one is the globe, which is made up of plastics to diffuse the light produced by the LED module. When you compare the incandescents versus CLOs versus LED, see how much difference. Lumens brightness, lumens, that is the brightness, 400 to 500. LED, to give the lumens of 400 to 500, LED watts need only 6 to 7 watts. When compared to CFL watts, 8 to 12 watts is required. But in incandescent watts, see 40 watts is required to produce the, for example, the first if we see the first as per the timetable, the incandescent 40 lamps, CFL 8 to 12 and LED 6 to 7 the lumens. Similarly, if we in the table so many comparisons are given, you can go through it. Incandescent versus LED, the watts used, average cost per bulb means if 60 watts incandescent lamp, when dollar and CFL $2, approximately LED 4 or less dollars. And if we use the bulb needed is for LED needed for 25,000 hours. Incandescent lamp is only 21 and CFL is 3 and LED is 1. The total estimation cost is of over 20 years. At last in the timetable it is given. So here incandescent lamp is 211, CFL is 54, and LED, if LED is $34 comparison. Average lifespan, if we compare the average lifespan of incandescent lamp is 1200 hours, for CFL 8000 hours, for LED 25,000 hours. LED TV. LED TV is a type of LCD televisions that uses the light emitting diodes to blacklight the displays instead of them cold cathode fluorescence light, that is CCFL it is called, as used as a standard LCD televisions. The LED TVs are most formally known as LED backlight LCD television. It is advanced version of LCD televisions. And LED is more efficient and a lot of smaller than CCFL. It is enabled to a thinner television screen. This is the configurations of the LED TV. The first one shows the full array LED backlights, then edge light backlights, and third one is the direct light backlights. Thank you.